So what is Orbit? So Orbit is our 1-year anniversary for the Filecoin mainnet launch. It was actually, yeah, maybe I can do a brief overview. IPFS was launched in 19th of October 2020, but that doesn't mean that work on this protocol started in 2020. After our ICO in 2017, we've been working with a lot of cryptographers to make this network ready. You can pay for a pinning service to pay your pin on their nodes. This has been the most common method for a lot of people who are not, one, interested in running their own nodes, or two, interested in running a cluster of nodes. So some of the services that have grown out of the ecosystem in the last 12 months include Pinata, Temporal, Infura, and so many more. So that's IPFS. But what about, we're talking about peer-to-peer communication, and IPFS has done a really good job of incentivizing people to change or to shift towards a peer-to-peer communication style. But IPFS is not a blockchain. So then how do we incentivize people to actually use distributed systems? Well, this is where Filecoin pretty much comes in. Filecoin is a storage network that is designed for the Web3 from the ground up. The way that you can think of Filecoin is that, one, it's not just compatible with IPFS because it was built on top of IPFS, but it's compatible with the entirety of Web3. And when we get to what the architecture of Web3 actually looks like, we'll be able to dive deep into what I mean here. And then Filecoin is also not just verifiable storage, but it's cryptographically proven storage. So not just when we say, hey, when a storage provider says, hey, I'm storing this piece of data, we don't actually have to rely on their word to believe them, because we have cryptographic proofs that actually ensure that they're storing data that they see that they're storing. And then the third thing is Filecoin is also a very massive decentralized network. But beyond these three things, really I could say Filecoin is also a community. And maybe we can just dive deep into what each of these three mean. So when you're using, I'm sure a lot of, okay, my bad, I should not have said that. I should not have said, I'm sure a lot of you can. IPFS, I would like to think of it as a layer that will support Web3, but some people may not believe that, right? So I cannot speak for everyone. That's just my own personal belief. I think Filecoin IPFS will make a really good layer, not just for Web3 itself or just for these networks, but for the entirety of the web. And what we've done in the last 12 years is not just integrating between Filecoin and IPFS, but integrating Filecoin with other frameworks as well. So in the last 12 years, we've built bridges for Neo protocol, Hedera protocol, Chainlink protocol, Polygon, Mask. I think I could go on. Like our key goal here is to make Filecoin as usable for anyone who wants to build any type of decentralized or distributed system to store that data on Filecoin. And like I mentioned, the cryptographic proofs that are used on the Filecoin network ensure that if a storage provider says, hey, this is the data that I'm actually storing, that when the proof of space-time, which is one of the cryptographic algorithms that runs the Filecoin network, does a randomness test to check, hey, is this data actually being stored? If the storage provider is actually not being truthful, what tends to happen is that they'll get slashed, they'll get penalized, and that incentivizes them to actually store the data that they see that they're storing. And again, Filecoin as a network has been growing in more ways than one, getting to about 8 exabytes of data stored, from storage providers across the world. That is pretty amazing. I mean, if you can think about how much storage Google has to acquire for themselves, and then think about the cost of that, and then think about people, storage providers, companies who are willing, to set up these types of resources to provide this storage for Filecoin users, it's pretty mind-blowing. So then what does our integration or Filecoin and IPFS being built for the entire Web3 architecture actually look like? So at the bottom of this graph or this funnel, what you'll see is Filecoin and IPFS storage. And the way that we're envisioning this is for pretty much anyone who's using or building with Web3 technology of any type, of any framework, to rely on Filecoin and storage as their first or go-to storage provider. And then we have storage helpers just above that funnel. And these are solutions that we built to kind of simplify the storing and the retrieval of this data. Storage helpers are actually pretty awesome for developers who would like to store on Filecoin and IPFS without necessarily having to work directly with Filecoin itself. I mean, just a disclaimer, IPFS and Filecoin are very, very technical. I think a lot of people who would be in the cryptographic space would also need a good chunk of time to actually understand a lot of the cryptographic elements that go into the network itself. Relying on storage helpers, we found that a lot of developers do not necessarily have to understand the full workings of Filecoin and IPFS to actually start working on IPFS, and that's why it's one of the things that we definitely recommend. And then just above storage helpers like NFT.storage or PowerGate or Estuary, we have the logic segment of the architecture. And this is where certain smart contracts or application logic is developed. And this is where our bridges to other frameworks have been very, very fundamental. Because if you're, for example, a developer who's working with Ethereum or Near or Hedera, do you have to really understand Filecoin to still store your data on Filecoin? Well, our answer is no. If we can give you the type of logic or the type of bridge that you would need to enable you from the platform or the framework that you're using to still store your data on Filecoin and IPFS, then we can absolutely do that. And then the last stack here for builders would be the front end. We still have a lot of good Web2 options here, but we're trying to make the push, for Web3. Like, can we really build front-end systems that rely on Web3 technology? Well, we think we can. And so how does Filecoin, we're saying, look, we think you can rely on us. We're saying we've built a protocol that can actually store humanity's most important data. What technology are we using to back that up? Well, the first way that we verify storage of Filecoin, or pretty much what this slide is the 4 or 3 steps that users and storage providers use to actually verify storage on Filecoin. And the way that I can explain it is, when you first make a deal on Filecoin, the first process that will happen is it will be chunked, and this chunking process is what will end up creating the directed acyclic graph, the DAG, which eventually becomes the Merkle forest. I really try not to make this very, very intense in its cryptographic terms, but if that's the direction any of you would like, I would be happy to explore that as well. And then so this uses the same process to generate CIDs for any data that has been added on the network. And once the CID has been generated, the storage providers will usually provide an initial proof of replication. What this means is, once your CID has been generated, it means that it's been added to the network. Once it's been added to the network, a storage provider who's interested in making a deal to store your file will say, okay, I have made a copy of that file, and I'm going to copy this code. I'm going to add this and store this copy of the file on my network. So this will be the file. The copy of the file is what will be published to the Filecoin network, to the Filecoin blockchain. And then over time, what the proof of spacetime does is that it runs a lot of randomness tests. And what these randomness tests do is just a proof of spacetime. And what I mean by proof of spacetime, which is the consensus algorithm that's running this verifiability test, is think of it this way. If I leave this chair here for about 2 weeks, and then someone comes and asks me, hey, is that chair still there? What kind of test would I run to actually verify that the test is there if I cannot see the chair? That's what a randomness test is. And that's what proof of space-time is. It's just a test to verify that the data that you say you have is actually there. And so how this specifically works is that the algorithm will send out a snippet of the CID that was generated in the first step and send it out to your mining hub or to your storage provider or to your node. If any piece of that CID is not found in your node, that means you failed your proof of space-time. And in that case, you'll get penalized. But if the algorithm actually runs the randomness test and finds the snippet of the CID that was generated still in your node, then the node itself passes the proof of space-time. And that means that that's verified stored data on Filecoin. Now, to retrieve data that has already been stored, we are working on something that we're calling a retrieval market, something that we're hoping to launch within the next 12 months. So keep an eye out for that. Okay, I'm gonna stop here for a bit because I know I have a couple more slides, but I want to take any questions if there are any. Yes.
If I have data that I don't want other people to know about, how do I deal with that? Do I have to encrypt it beforehand, or is there an option for storing private data?
Great question. Privacy and encryption is something that is definitely always a question, especially for blockchain, because what we claim is that we're building public networks, and we say we're building public networks as a way to stand against people who've used our data that we gave them, and violated our privacy. But, how do the two really gel? You mentioned a really good one option, which is encrypting data before adding it to the blockchain network. That's usually a very good way to go because permissioning for a lot of these blockchain networks is something that has really gotten better over time. And so we have a lot of different permissioning systems built within different types of access controls like wallets that really verify that you're the person who has to access a certain type of data at any given time. One of the ways that you can also do that with Filecoin and IPFS is running node clusters. So this is something that I had mentioned initially. So if you want to work with a smaller group of people, if you have large data sets that should only be accessed by a certain type of people, you can make this data available within certain clusters or within certain node clusters so that only the people with access to those types of nodes can have access to that data as well.
Okay, another question. The current Web 2.0 is built on a naming system, the domain naming system, which changes like, okay, let's say I go to Chrome and search, let's say I go to Chrome and search YouTube. That information will be changed to IP address, which is the IP address of YouTube. So like in now IPFS, like how will it know that it is this specific information that I'm searching without knowing the specific node that you understood it?
Great question. So location-based addressing, I think, is one of the major flaws that we pretty much identified with Web 2. And this is the URL-based systems, right? And of course, it heavily relies on DNS. And I don't know how many of you actually looked into one of the reasons why Facebook went down last week is because their DNS servers actually went down. And that means that anyone who wanted to find any Facebook server had to have the actual IP address of the DNS to access Facebook. And as you can see, that is a major flaw. I do not need to know the IP address of a server to access data from it. So with IPFS and Filecoin, what we do instead of location-based addressing is content-based addressing. And I can just go back to the slide that we covered here, which is this, right? Every time a file or a folder or a website or anything is added on the IPFS or Filecoin network, it's given a unique cryptographic ID. And this cryptographic ID is what you can use to locate any information or any file, regardless of which node is holding it. So if you have a CID of any file or information that you're looking for, you can do a query on either IPFS or Filecoin, and you can have access to that data without really knowing either who's storing it or which node is actually perpetuating it or retrieving it. And I think that's one of the major advantages of content-based addressing versus location-based addressing. Awesome. Okay, then maybe we can continue just a bit, and then we can take additional questions at the very end. So yeah, so what we've pretty much described is what IPFS is and why it works so well with Filecoin, right? IPFS is for fast, flexible retrieval, and this can happen through gateways, local nodes, or browsers. I love browsers. And Filecoin is for more persistent, longer-term, verifiable storage. And putting it that way, I also don't want to just, put Filecoin in the bracket of it's just a network, it's just a protocol, despite that, it's some of those things. A lot of builders have access to different types of libraries and tools and services that they can use to build different types of applications. And as I've previously highlighted, we've seen more than 500 new projects come out of Filecoin in the last 12 months alone. And so we have, for example, 4 different implementations of Filecoin. One that's written in Go, one that's written in Rust, and one that's written in JavaScript. So if you're a developer and you're thinking, oh man, how do I get started with, with working with Filecoin directly, if that's something that you're interested in, you can have a look at the different implementations that we have and see if, it's something that you'd be interested in working with. We also have different tools and libraries. We tend to call them storage helpers. This would be like NFT.storage or Web3.storage or S3 or PowerGate. Really good libraries or really good services that developers can also rely on. And like I mentioned, work has been growing exponentially. And this is just a quick overview of what we're working with to date. We're just at over 1.2 billion blocks. And so far, the pledge on the network for storage miners has reached close to 120 million fill, and this means that the pledge from storage providers to keep storing storage is just increasing on the Filecoin network, and you can see the active number of miners. We are at 3,405. It would be great if some of you could also become storage miners and provide free storage to the rest of the world. So, what can I build with Filecoin? Well, the way that we have thought about the stack for Filecoin is that you can absolutely use Web3 all the way down your building funnel, all the way from asking your browser from a CID, all the way to this example of Uniswap, for example. This is built on Filecoin and IPFS, and it's a browser-based service. And the way that you can start using Uniswap is when you go on uniswap.org, for example, and you want to swap out one of the coins, is your browser will ask the IPFS network, because this would be a Brave browser, would ask the IPFS network for the CID of this application. And then the front end will load with IPFS, and then you'll be able to log in with DWeb. So this is part of the permissions. If you're using a wallet, this is usually the best place to log in with a wallet. And then storage helpers would fall in this category because, as opposed to, like I said, storing your data directly on Filecoin or building directly on Filecoin, you can rely on storage helpers to help here. And then finally, the information will be retrieved from the Filecoin and IPFS network. And the way that we're looking at this stack is that developers do not have to rely on a lot of Web2 stacks to build new solutions, that you can rely on a lot of the solutions that we're already building to build out decentralized applications all the way through. So what are some of the storage helpers that we can work with here as developers? Well, Fleek is an IPFS hosting platform. This is perfect if you want to share your websites, if you want to share your applications, if you want to share pretty much anything, censorship-proof, information with the rest of the world. And this works with pretty much any framework that you can think of. Docker is a good place, React as well. If you also like Webflow, Fleek also has a very good integration for that. And the way that it works is that you create a GitHub repository with the file or the website or whatever it is that you want to upload on the Filecoin network. And then you add in your build settings. And once you've added in your build settings, what GitHub will do through the GitHub Actions, because we have a GitHub Actions tool that actually allows you to store data directly to IPFS and Filecoin from GitHub, is that it will run this action and then deploy your site to IPFS, and then it will be backed up on Filecoin. So like I said, this uses GitHub Actions, the CLI, that is the command line interface, and then the GraphQL HQ API. Some other storage helpers, if you want, I've mentioned the word storage helpers a couple bit, but maybe just to explain what I mean when I say why storage helpers, why would I recommend this as opposed to building directly on Filecoin and IPFS? One of the best things is that we have really good workflows with a lot of the storage helpers that we're building. So NFT.storage, Web3.storage, Powergate, S3, these are all built by individuals and companies within the Filecoin ecosystem who wanted to make it easy for other people to work with Filecoin. And they've been working on simplifying the different types of deals and workflows that will make it that much easier to actually get started here. And then they also help, like I mentioned, simplifying deal making. I don't know how many of you have actually tried to store files on Filecoin, but one of the biggest challenges, if you wanted to do it directly, was finding storage providers to actually make deals with. So with these storage helpers, storage and deal making is completely free. And in some cases, some developers would be amenable to making payments for these types of storage. In that case, working with a storage helper makes it easy to negotiate these types of storage deals. And then you can store, on IPFS and Filecoin in one simple call, as opposed to multiple different calls and running multiple different terminals. Working with storage helpers makes it more of a one-click type of solution. And then the Fleek Space Daemon. What is this? So this is designed for building desktop applications. You're a developer, you want to make really good applications that are not ideal for the web or are not ideal as web apps. This would be a perfect tool for you to use. And it's a combination of a lot of the technologies that we already use within IPFS and Filecoin. So that would be IPFS, textiles buckets, Powergate, which I will go into just shortly. And then it also runs on your desktop, so it gives you the perfect environment to test your applications within your development environment as well. And it can definitely be bundled with other desktop applications. To use this, all you need is a JavaScript client and a gRPC API, gPRC API. The third storage provider that we offer for developers would be S3. And S3 was just built in the last, I think, 4 months. And so far, we've been able to use it to make up to, I think, what was the last number I looked at? Close to 4 million verified storage deals. And that is a pretty incredible feat. This is perfect for general IPFS and Filecoin usage. So if you just want to store or make deals for storage of data on Filecoin, S3.tech would be the best place to do it. And the data is immediately uploaded to Filecoin and IPFS, and it stays with up to 5 or 6 storage providers across the world. So if one storage provider, says, I'm tired of running my node, I want to shut it off, there's additional storage providers who will keep copies of your data. To use this, definitely need HTTP API and a web interface, because this is a web-based solution. The data may not actually be that visible, but if you see down here, this is the estuary page, and what the green represents here is total successful confirmed deals for storage on the network, and these are waiting confirmation. So you can actually get on the website itself a live view of how the storage deals are happening on Filecoin and on estuary. And then NFT.storage, this is perfect for NFT enthusiasts. So if you're working directly with NFTs of any type, NFT music, NFT art, NFT, whatever it is, NFT.storage would be the best tool for you to use. All you need to do pretty much is upload your data. And once you get your CID, this is immediately stored on NFT.storage. And storage and retrieval for NFT.storage is completely free. So, and it actually gets backed up on Filecoin as well and stored with multiple storage providers for permanency and persistence. You will need a JS client library for this, so that would be the JS IPFS, and then you'll also need to work with a configured remote pinning service for this. And then lastly, it's PowerGate. PowerGate is my favorite. I shouldn't have a bias, but I do. It's my favorite because it enables developers to do a lot more with the application when they're using PowerGate than with pretty much all the others. The others are more of click, 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 and then everything is done. But with PowerGate, you actually have to do a lot of sourcing, because you'll be working with JS and Go clients of Filecoin. You'll also need to do. You'll also need to work with several commands, because and this works with the command line interface, and it works with Docker containers, which runs both an IPFS node and a Filecoin node, and you can use it at any given time to store, retrieve, or state your data on Filecoin. And one of the best things I love about it is that it provides default configs for miner selection. And what this pretty much means is, once you've prepped your data, once you've prepped your application, once you've prepped your website, and you're ready to publish it either through a bridge or through to Filecoin through PowerGate itself, PowerGate will present you with default configs for different types of miners to select from, which makes life pretty easy. So yes, so based on the different types of storage helpers that I've gone through, you can see exactly why we would recommend using or relying on a lot of storage helpers to persist data on Filecoin and IPFS. And our goal is, once we've built out a lot of our logic flow and built out all the different types of bridges that we can really build with all the different frameworks that we have coming up day and night, is that anyone can enjoy all the different possibilities of decentralized technology and decentralized networks. We have resources that you can use to kind of keep learning. We have resources for getting started with IPFS and Filecoin. We have a website, proto.school, which offers some great interactive concepts and tutorials. We also have NFT.school, if you're more inclined to learn about NFTs and what all the rage is. And then if you're a developer and you just want to interact with other people who are passionate about Filecoin and IPFS and Web3 as a general subject, you're welcome to join us at one of the dozens of virtual hackathons that we host every single month. I think that will be it for now. You can also reach out to me on Filecoin Slack if you're a Slack user, or if you have any questions about what it's like building with Filecoin. We have an entire builders team that would be very interested in helping you navigate any of the challenges that you may face. And with that, we also offer support for independent projects, up to 5,000 of funding for any project that would be working with either IPFS or Filecoin, and you are very welcome to submit your proposal. You may not know in details what you want to do with it, but if you have an idea, we'd be happy to help you flesh out what that would look like as a final end product.
Okay, I've seen that the storage, okay, IPFS storage facility or something are free. So like, how do the developers earn money? Do they like sell ads or something? Okay.
Okay, storage providers earn rewards, or what we can call mining rewards. Couple ways that they do that. Every time they pass a proof of space-time, they get a reward. Every time they confirm a block, they get a reward. That's two of the ways that we've been able to incentivize storage providers to join the network.
So you said for the NFTs, the storage is free. But now for like the files that companies want to upload onto the Filecoin network, they have to pay for them. And that's why they have to use storage helpers who help them negotiate for these files to be stored, yeah? You said, is that what you said?
Deal making, couple ways that it works. If you're a large storage user or data storage user, or you have such large data sets, because like I mentioned, if you're storing something like an NFT, which would be less than 5 MB, it wouldn't make sense, for a storage provider to charge you for that. But if you are, for example, a large institute like NASA, and you had large data sets of space data that goes into maybe up to, 50 or 60 terabytes worth of data, those are the types of, users that we charge for deal making, not for developers who would be working with maybe smaller or, in terms of sizes of the data sets, or also in terms of the size of the files themselves. So a lot of the deal making is towards more bigger clients and larger clients that would have larger kinds of data sets that would have perhaps even more value for humanity. So for example, one of the things that we've done with Internet Archive is we've been trying to crawl the entire internet for dying languages. And what we found is that there was close to about 50 languages that are dying, and because their URLs keep going offline every year, we wanted to save these languages for the rest of humanity, a couple of years down the line, where we want to say, hey, what were people doing in 2021, we would have this data stored on the Filecoin network, and this type of data comes in close to about, terabytes and petabytes worth of data, and we usually tend to upload it to specific storage providers who provide a unique deal to store that data permanently forever. Awesome. Thank you, everyone. I'll be around for the rest of the day if any other questions come up, and I will be happy to also have different types of conversations.